Hello friends, I hope you like my videos. So today in this video we will discuss about the very important topic in the pharmaceutical quality system, that is FMEA, which is called Failure Mode Effect Analysis Tool. Friends, my YouTube channel name is Pharma Quality, so please view, like, comment and subscribe my channel. So now first we will understand what is FMEA tool. So the failure mode and effect analysis, or FMEA, is a systematic approach to identifying and addressing potential failure in a process or products, right? So a failure mode refers to the specific ways a process or product might fail to perform as intended. So the FMEA involves analyzing these failure modes, understanding their potential effects, identifying the root cause, and implementing the action to mitigate or prevent these failures, right? So by systematically evaluating risk, FMEA help to improve reliability, safety, and overall quality in process and products, which ensure compliance with the industry standards and regulations, right? So now here we will discuss about the FMEA tool, that is when it is to be used, right? So the purpose of FMEA is to take action to eliminate or reduce failures, starting with the highest priority ones, right? FMEA helps document current knowledge and action related to potential risk and failure, which creating a foundation for continuous improvement. So basically, FMEA tools and its approach is particularly valuable during the design phase, where it helps to prevent failures before they occur, which ensure the reliability and safety of product and processes, right? So now here we will discuss about the key terms in FMEA tools, right? So first one is the failure mode. So this refers to the ways in which a process or product could fail. Next one is the effect. So these are the consequences or outcome of the failure, right? Which often impacting quality, safety, or performance. Next is cause. So the underlying reason or root cause behind the failure. So to prioritize these risks, FMEA uses the risk priority number, which is called RPN. So the formula for RPN is severity into occurrence into detection. So this calculated value helps to determine which risks require immediate attention, ensuring that high priority issues are addressed first. That means if the risk is higher, then you need to take the corrective and preventive actions, right? So the calculation criteria I have explained in my last video of quality risk management. So you can refer the criteria from that video. And also I'm putting the link into the description so that you can refer, right? So now in this slide, we will discuss the types of FMEA. So first one is the design FMEA. So the design FMEA is a systematic approach used during the design phase of a product. It helps identify potential failure modes, their effect and their causes before the production begins, right? So at the time of procurement, these design FMEA need to be implemented, right, to assess the risk. So the primary goal of the design FMEA is to improve product design, enhance reliability and reduce the risk. And here are some key elements which include, first one is the function analysis of components. So with the understanding the roles and interaction of each component in the design, right? Next is the identification of potential design related failures. So here pinpointing areas where the design might fail to meet the performance or safety standards, right? Next is the implementation of corrective action. If your risk is identified is at higher category, then you need to take the steps to eliminate or reduce the risk identified during the analysis, right? So by addressing potential issues early, design FMEA ensures a robust and reliable product design, right? So let's understand the next, that is process FMEA. So the process FMEA is a structured method used to identify and analyze potential failure modes within manufacturing or assembly processes, right? So the objective of process FMEA is to enhance the process reliability and ensure consistent product quality, right? So this process FMEA, when we can use at the time of routine process activity, right? So the few key elements which includes, first one is analyzing each step of the process, where examining every stage to identify potential weak points, right? Next is identifying potential process related failures and their impacts. So here understanding how process deviations can affect the final product or performance, right? Next is developing controls and action to mitigate the risk. So implementing the preventive measure and corrective action to address identified risks if that risk is at higher category, right? So by systematically addressing process related risk, process FMEA ensure a smooth operation and high quality outcomes, right? So here let's understand the design FMEA and process FMEA with an example. So here I am taking just one random example from isolator, right? So here several other requirement and processes can be evaluated in the same way. So let's first understand with design FMEA, right? So let's take one example that your requirement is like designing an isolator system to provide unidirectional vertical airflow. So your step will be non-uniform vertical airflow over the working area, and the harm could be contaminated working area leading to compromised product sterility. So severity I have written here as 5, right? So the next is cause of harm. So cause of harm which may include poor design of airflow distribution, incorrect HEPA filter placement, inadequate fan capacity, right? And the occurrence for this I have ranked as 4, right? So in the next column you need to provide the existing control. So existing control could be computational fluid dynamics simulation for airflow design, HEPA filter efficiency validation, fan capacity calculation, particle detection feature, right? And the detection I have assigned as 1. So the RPN calculation, that is S into O into D, is equal to 20. So the residual risk shall be accepted and there is no need to calculate the RPN, right? So you can take this example to design FME, right? So now let's understand the next example for process FME. So let's say your requirement is operating the isolated system to maintain unidirectional vertical airflow. So the process unit or substep could be deviation in airflow velocity during routine operation, right? And the harm for this requirement can be increased risk of microbial contamination or particle deposition. So the severity for this I have assigned as 5. So next is the cause of harm. So cause of harm could be blockage in the HEPA filter, incorrect system maintenance or calibration, equipment wear and tear, right? And next I have assigned the ranking as 4 for the occurrence, right? So here we need to provide the existing control. So existing control could be preventive maintenance schedule, routine airflow velocity checks, environmental monitoring program. Next is the detection. So I have assigned is as 1. So the your RPN calculation will be 20, right? And the residual risk shall be accepted. And again, you don't need to recalculate the RPN, right? So overall, in this way, you can draft the FMEA for design of equipment and for process of equipment, right? So friends, this is all about the FMEA tool. So thank you so much for watching the video.